Hope everyone are able to see the screen, I guess. Okay, fine. Um, so in the first unit, generally these are the concepts, or these are the frequently the questions that will be covered, or that will be expected things that might be appear in your JNTU pattern. In the first chapter, you have something called as computer system. You have different types of computer languages. Then you have computing environments, how to create and run your programs, your system development, program development. The first six concepts are related to chapter one. Okay, the theory questions can be covered. I mean, you can expect them for short 1 mark questions, and you can also expect them in your long answer questions. Now, from structure of C program to precedence and associativity are covered in under unit 1 chapter 2. Okay, you will be having it under unit 1 chapter 2. So today we'll first complete chapter 1 concepts. So for unit 1 we will be taking a couple of days because you have more concepts here. Okay, and you have more theory part actually. So today we'll try to make sure that chapter 1 concepts are covered clearly. So and how you are going to attempt that if that particular question is given, even that I'm going to share you. So now first we'll talk about computer systems, computer languages, and computing environments. Okay. Now, so the first thing, if you're talking about your computer system, so if you're talking about your computer system, um so your computer system is broadly classified as two things. You have different things. If you have an idea, can someone say what are your different computer system things you'll have? Your computer system is having two different things. One is you'll be having your software structures, and the other one is nothing but you will be having your hardware units. Fine. So you'll be having your software and you'll be having your hardware units under software and hardware. What are the different components involved and what are the categories of software we have to talk? So when you're talking about this question, if it is for 5 marks or if it is for 10 marks question, generally you will be not given for 10 marks question. This will be covered for 5 marks. So first you have to write the definition of your computer. What is a computer? First of all, you all know that computer is an electronic device. So the first you'll be writing the definition of computer. So definition stands for, first, computer is an electronic device which is allowed you to do some mathematical and logical operations. This is the small definition which you have already studied when you I mean in your school times. Okay, it is a electronic device which allows a user to perform mathematical and logical operations. Okay, so this is a small definition of your computer. Now, after that, what is a computer system? Your computer system is broadly classified as two things. The first one, we call it as hardware. I'm talking about the first concept, hardware. And the other one is you'll be having software. So what is hardware and what is software? So whenever you're talking about software, software is nothing but something called as a set of instructions. So understand, dear students, whenever you write some programs on your system, all these in whatever the lines of code or piece of code you're writing, all these are called as set of instructions. Okay, and with in order to execute this set of instructions, we will be using something called as software. Like you can say indirectly, a program is nothing but you are calling it as set of instructions. So your program is nothing but it's called as set of instructions In order to implement these set of instructions, we'll be using different softwares on your systems. Now, when you talk about softwares, again, your software is broadly categorized as two things. The first one, we call it as application software, and you also have something called as system software. So whenever you're talking about the term application and system software, so see the term, uh, if you see the term application and system software, application software are used only for particular purpose. For example, let's take you are playing some games. Okay, suppose let's take you are familiar with different games, like you have let's take like you play Candy Crush, right? So in order to execute that instruction, that is in order to play that particular in order to play that game in your mobile phone, definitely you need application for that. Okay, now one more thing you have to remember is, whenever you are talking a term called as application, it is very relatively related to which type. Suppose if you want to have, or if you want to store some images on your mobile phone, definitely you need your image, your application which is capable of storing images in your system. Suppose if you want to make any video, definitely you need some application which is related to video. So applications are for user defined. That is nothing but if a user needs that particular application, is going to install, and if your user doesn't need that particular application, there is no need for a user to have his application software on the system. Now when you're talking about system software, now you can take the best example of your system software as your operating system. So in order to run any of your instructions on your system, that is if you want to relate your programs, that is nothing but in order to relate your set of instructions to work on your system, definitely we need some interface which acts between the user application and system defined. So now your operating system is the best example of system software, because operating system will act as interface between uh, so operating system will act as interface between your operating system act as interface between user and system hardware. Okay, so under system software you can give your best example as operating system. So can someone give me a small example which is related to application software which we are using in our daily life, and what is another than operating system which acts as an, which can be coming under the category of system software? So by seeing the name, you should understand application is specific for one particular application, whereas system software is not specific for one application. It is completely purely related to act as an interface between user applications and your system hardware. So there I gave you a best example as your operating system. So I'm asking you one question. Can you give some examples which are related under application software? Yes, you are correct. You can use your MS Office and MS Word under the category for your application software. And for system software, so you can even use your DBMS if you are familiar, database management system. It is DBMS is also a system software, because whatever the data entries you have on your system, they are being stored at your backend procedures, right? So now when computer system is given, so you will be writing the related concepts which are related to hardware. First you'll write the definition of computer. What is a computer? A precise definition. Then how your computer system is categorized? Computer system is broadly categorized into two things. That is nothing but you're going Hello, are you able to hear my voice now? Okay, fine, fine. I guess someone has been making it has some problem. Okay, okay, fine, sir. Thank you. Um, okay. Um, Sorry, some issues on the network side. Fine. So hope you are able to hear now. Thanks. So as I mentioned, so you are going to categorize these computer system as hardware devices, and you are going to make it as software. And we are discussing about software. In the software system, you are going to again categorize them as application level software and system software. Okay. So as I mentioned, your application softwares are related only for particular things, or it is only used for particular applications in order to run your particular applications. Okay. Now, this is a small definition of your application and when you're talking about system software. Now, you also have the classifications of your software, not only are related to system software is one thing what I told you, and the other one is you have application level software, as I mentioned. Now, when you're talking about system software is again broadly categorized as three things. The first one, we call it as operating system. Okay. The second one, you have system support, and you have the other one as system development. Okay. So your system software is again broadly categorized as operating system is the first one. The next one is system support, and you have the other one as system development. Now, as I mentioned, operating system is nothing but which is acting as an interface, or it is acting as a communication between the user and your system hardware. The same definition which is going to be followed here. Now, when you're talking about system software, system support system, okay, what a system support system is, it is going to provide the system utilities. That is nothing but what are the useful things which are related for your for the processing or for providing the services of operating I mean, in order to in order to achieve the services which are related to operating system, your systems of support software is going to do that. Like for example, let me give you example, you'll be more understanding. Let's take your disk format programs. So disk format program will help as a support system software in order to provide the services which are related to OS. Now, what does disk format? Why do we need disk format programs, or why we need disk formatting softwares or something like that? Is suppose if you have any problem of any maintenance related to your operating system, then we invoke the system support softwares which are already inbuilt. Okay. Now, when you're talking about system development software, it is helping, like it is going, it is it helps you to convert the programs. That is, it has some translators which will convert your programs from machine language to the required format according to the user. In simple terms, you can say system development softwares help you for making error free programs. Okay. So once again, so under system software, we have three things, whatever I told, like operating system is one thing. Then you have the other one as system support software. And the other one we have it as system development software. Okay, this is under your system software. Okay, so under your system software, this so operating system which is acting as interface in order to run your applications of the user which are related, and it provides an interface for the user applications with hardware. When you're talking about system support software, it will provide the system utilities and other operating system services. Like best example for support is disk format programs. This format programs will help, or it provides a user to use its utilities. Now the next one is you have the system development softwares. Like best example is where you have your debugging tools. Okay, and you also have some converters. That is nothing but you'll be having some translators. Why do we need translators? Translators help a user to convert a machine level program to any another language. I don't say it is only to high level language. It can be assembly language or user friendly language. Okay, so system development softwares help in that. Okay, so these are the three things which are enclosing under system software. Now the next one is we have something called as application software. In application software, as I told, application softwares are generally used for a particular applications. Okay, application softwares are only used for a particular application. Now these application softwares are again divided into two things. The first one is we call it as general purpose software, and the other one is application specific software. Okay, so again your application level software is divided as two things. The first one we are calling it as general purpose software, and the other one is application specific software. Under general purpose software, this is like, for example, you will be having your word processor. Like this is a software which is generally developed by sophisticated users, and it can be used for more than one applications. Okay, like for example, remember one thing, general purpose softwares are always designed by a software developer. Like you can consider him as a sophisticated user, where whenever these applications can be used for more than one application. Like you can take your word processor. Okay, and we are calling this name because they are going to solve different computing problems, user computing problems. In this general purpose software, these can be used for solving different computing process. Like you can also take your library methods, where you have different things which are going to solve. You'll be having excuse me, you'll be having your library methods, where a library method can be used for different user computing problems. So these are general purpose. Now when you're talking about application specific, as I told, they are only used for one particular task. They cannot be used beyond some another thing. Okay, always your application specific software can be used for application level software can be used only for one particular process, and general purpose software can be used for more than one. That is, indirectly this general purpose software help a user to solve different computing problems. Okay, now this is about your computer systems software. When you're talking about your hardware structure, okay, you have different types of hardware units. Like you'll be having your, you can take the best example, like you will be having your computer hardware which is categorized as, so your computer hardware is firstly categorized as different components. Like you'll be having your input output devices. Okay, then you'll also be having your primary storage. Then we also have something called as auxiliary storage and your CPU, central processing unit, and you have auxiliary storage. Okay, so you're all familiar with your input and output devices. Your input devices, you can take your best example as keyboard, which help a user to enter his instructions, which can be displayed on your computer. And you can also take like mouse is also an input device which is helping you to do some user friendly annotations. Now when you're talking about output devices, you can take your best examples like uh, printer is working as an output device for you, right? Now the main thing is we are talking about central processing unit. When you're talking about central processing unit, you have to have this architecture to be shown. You'll be having like this is your input, this is your output. Under central processing unit, you again have something called as memory unit, mu, control unit, and you have your arithmetical and logical unit. Okay, in hardware units, when you are explaining CPU, try to draw this block diagram. What is CPU responsible for? First of all, a CPU is responsible for executing the instructions like arithmetic and logical operations. The arithmetic and logical operations which are related, those are responsible for CPU. Not only that, CPU is also responsible for comparison of data. Okay, first it is responsible for arithmetic and logical operations. It is also responsible for comparison of data, and it is also responsible for movement of data inside your computer system. Okay, it is also responsible for movement of data. When you are saying a term called as movement means it's not moving from C drive or D drive, something like that. You are moving your instructions from secondary storage to your primary storage, because all your instructions have to be loaded onto your primary storage, then only they are capable of executing by your processor. Okay, so now this is about your CPR. Now CU is stands for control unit, as you all know, which is helping a user to control all the instruction processing cycle. MU is memory unit, where your instructions have to be stored. That is, whenever you are allocating some memory locations, your MU plays a key role. ALU is arithmetic and logical units. All your arithmetic and logical operations are carried out by your ALU. Okay, so always remember one thing, when you are talking a term, CPU is responsible for movement of data. It's moving the data from your secondary storage onto primary memory. Okay, or you can also call it as main memory. All the instructions which are designed by the user definitely have to be loaded onto your main memory. Then only your program will be under execution. Okay, then next, you also have a term called as auxiliary storage. Okay, input devices, output devices, you have your primary memory, then you have your CPU, then the next one under hardware we have it as auxiliary storage. What is this auxiliary storage? Auxiliary storage is also referred to a term called as secondary storage. We call auxiliary storage also as a secondary storage device. Now, this secondary storage device is used for both your input and output actions. Okay, and whatever the data we are going to store on this auxiliary storage or secondary, the data is always permanent. In your main memory, it will not be permanent, and the instructions which you are going to do, or the in what do you say, or the files which you are going to execute, if you are loading onto auxiliary storage, they are permanently stored, which helps for the next time whenever we need. Okay, like for example, you have written a program and you are going to save that file. The saving of that file happens on your secondary storage. Why do we need to save your file? In order to refer it for the future use. Okay, so this is about your computer system. Hope everyone understood with computer system. Anyone has any doubt what to do? So first you will carry it out with definition of computer. Then you will categorize broadly them as hardware, and you are going to broadly categorize them as software. And under hardware, you are going to talk about input, output, your CPU, then your auxiliary storage and your primary memory. Under software, you are going to broadly categorize as system software, and the other one is application level software. And again, under system software, you're talking about operating system development softwares. Okay, and under application level, you're going to talk about general purpose software and application specific softwares. And you are going to draw the block diagram of your hardware of which is related to CPU. Everyone understood the concept of computer system? Can I go with the next concept? Okay, fine. So let's talk about computer languages. So first one, your computer languages. Okay. Before me speaking, let me know what are different computer languages do we have? What are different computer languages do we have? Right. So first, foremost important point is, please, when someone asks you a question like what are computer languages, please don't say C, Java, Python, Fortran, Cobol. No, they are not your computer languages. They are the programming languages. Remember, very important. Many of you may do this mistake. So never do that, utter that mistake. Computer languages are broadly classified into three things. The first basic thing, you call it as machine level language. Next, we have assembly language. Then we have high level language. Okay, so when you're talking a term called as machine level language, assembly, and high level. So first, computer language. Okay, so your computer languages are broadly categorized as three things. The first one is machine. Then you have your assembly level language, and then we have high level language. So first, we'll talk about machine level language. So when you say machine level language, first thing we are going to say machine level language is non-human readable form. Okay, it is not understandable by human. It is a non-human readable form. Always a machine level language is represented in the form of binary. The representation is always binary. When you say binary representation, the representation of binary language will be always in the terms of zeros and ones. Your machine level language is always represented in the form of zeros and ones. Okay, and the representation of zeros and ones, we are calling it as binary language. Okay, so first machine level language is a non-human readable format. If you normal human cannot understand what is machine level language. And next, it is represented in the form of zeros and ones. Okay, next foremost thing is, what is zero and what is one. Whenever in a computer system, a zero always represents an off state and one always represents an on state. Okay, so whenever if in when you are working on with an internal circuits, like for example, you all know transistors, electronic devices like switches. So switch, if you take a switchboard, you'll be having two states only. One is off and on. That on state is represented by zero and on state is represented by one. So first in machine level language, it is a first you can write it like this. Machine level language is a first programming language available for machines, and it is a non-human readable form, and it is represented in the form of zeros and ones. It is why we do represent zeros and ones is you will be having your internal hardware architecture with some switches, transistors, and electronic devices. So all these devices only takes two states. One is off state and the other one is on state. Always an off state represents a value as zero, and always an on state represents a value as one. Okay, so this is what a machine level language is. One second. Next, next we have the next one is assembly level language. Next we have the assembly level language. So some say it as assembly level language and some books say that it is symbolic language. So by name you can understand symbolic. So assembly level language is also referred as a middle level language. And always an assembly language is represented in the form of symbols, and we represent that symbols as mnemonics. Remember, the representation of assembly level language is called as mnemonics. M is silent here. You call it as mnemonics, which is nothing but combination of different. You can call that as a combination of different symbol. Okay. Next we have, how do you represent? For example, let's take in earlier you have to give here one example. How do you write your assembly level language programming? So first, assembly level language is also called a symbolic level language. You can also call assembly level language as middle level. And how do the representation of assembly level language will be there? Assembly level language is represented in the form of mnemonics. When you are saying a term mnemonics, it's nothing but group of symbols. Now, in earlier stages, for example, I want to write a simple thing to add. Uh, let's take you want to perform some addition of two numbers. So what they used to do is add something like A and B. When you are saying this add A B, we understand that your A B are your operands. That is nothing but they are variables, and this add is a word that is nothing but a mnemonic, which where you are clearly specifying your device or your compiler to understand you want to perform the arithmetic operation on two words or two symbols, sorry, two variables. That is nothing but add. Suppose if I want to do division, they used to use div, that variable names like n1, n2. So assembly, that is the reason we are calling assembly language also it as a symbolic language, because you are representing all your operations in form of mnemonics, that is in the form of symbols. Okay. Now, so next we have high level language. So first, high level language is a human readable form. First, you have to understand high level language is a human readable form. Then, high level language is represented in the form of alphanumerical mode. Okay, high level language is a human readable form, and its representation is in the form of alphanumerical mode. What do you mean by a term called as alphanumerical mode? Means it is always a combination of alphabets, numericals, and special symbols. These are nothing, that's the reason, as it is combination of alphabets, numericals, and special symbols, we are calling high level as a alphanumerical mode language. I mean, it is represented in the form of alphanumerical. The best examples for your high level programming languages, you can give it as like your C, your C++, Java, and so on. Okay, all these comes under the category of your high level languages. Okay, so hope you understood. So computer languages majorly are helpful for a user to design his instructions. And these computer languages are broadly categorized into three types. The first one, we are calling it as machine level language. Next, we have assembly level language. And the third one is high level language. Under machine level language, machine level is a non-human readable form. In earlier days, the first programming language was machine level, which is represented in the form of ones and zeros. What is this 1 and 0 is? All your electronic devices are made of some switches, transistors, and etc. So always an on state is represented as 1 and always an off state is represented as 0. And this representation we are calling it as binary representation or binary form. Now, after this, as we have disadvantages in machine level language, because it is very difficult for a normal user to enclose or encode his program, your machine level language has been later moved on to representation with symbols. That is nothing but the next level language is assembly. Assembly level language is also known as symbolic language, or few say that it is also a middle level language. And the representation of your assembly language is always in the form of mnemonics. Your representation of your assembly language is always in the form of mnemonics. Mnemonics is nothing but you're representing your actions, or you're representing your instruction set with some symbols. Like for example, if I want to perform addition of two numbers, I'll be writing a symbol like I'll use a mnemonic as add followed by variable names. Now, as even it is very difficult, they have made more user-friendly programming language. That is nothing but we have the next category as high-level language. High-level language, the first foremost point is it is a human readable form. Next, all your high level language instructions are represented in the form of alphanumerical mode. When you are calling a alphanumerical mode, always a high level programming language is combination of alphabets, numericals and special symbols. So that's the reason we are calling high level programming languages alphanumerical mode. Now under high level language, we have the best examples like C, C++, Java and so on. Okay, this is about your computer languages. Hope you all understood this. Computer languages. Anyone has any doubt? Okay. So next we are talking about computing environments. So first you understand what is meant by environment. Environment is nothing but you are making a user or a user is making his working environment according to his own architecture. Like a user can have different types of environment in order to design his instructions or in order to start his programming set. Like environment is nothing but a place how I mean you're creating a workstation, how you want to invoke your set of instruction. So these computing environments can be categorized as the first one is personal computing environment. First one is personal computing environment. Okay, when you are talking about personal computing environments, understand under personal computing environments, we will be having only one person. Okay, where one person is interacting with his system hardware and he is creating his set of instructions. The best example is your desktop. Okay, you will be having your laptops, or you can take your best examples as your palm tops. Okay, in personal computing environments, you are designing your environment for working model in such a way that only one user is going to participate on this model, or one user is going to be present on this environment, and he is going to create his set of instructions. The best example is your desktop, laptop or your palm tops. Now under this computing environments, next we have time sharing. The second one is time sharing platform. Okay, now when you see the term time sharing environment, so you understand here you have designed some architecture or you are providing some environment where you have to use the technique of sharing the devices. Okay, I don't say we have here only one or two or three, whatever it is, the architecture when you design, you are going to share that environment depending on a factor called as time slots. Okay, I'll give you an example. Suppose you'll be having some different class. You people, let's take your CSC. So CSC, you have n number of sections. Let's take your CSC A student. So you will be having a classroom which is shared by all the students. That is fine. Okay. Now when you want to listen to the classes, okay, all the subjects will not happen. You'll be having your time slots. That is, you'll be creating a timetable. Like for example, 9 to 10 this subject, and suppose if you don't create the time sharing for that particular classroom, what happens? All the teachers at once comes and you can't mess up that. So whenever you have a common thing to be shared by n members, or whenever you have a common thing that should be shared in between n different people, then the best environment you want to create is time sharing. And for example, you're working for an organization where you have only one printer. Okay, for let's take in your workstation you have 10 people working there, and for 10 people you have only one printer. Now if I don't keep this time factor there is a chance that all the people will go at once, and it is clumsy there. That is, you don't have a proper organization. So what happens? Then they go for time slots. So in the similar way, in your how this time sharing environment helps in your system is you'll be having different resources. Okay, these different resources have to be parallelly shared by parallelly shared by different application programs. So in that case, what is, for example, you have three documents. Let's take, you have an image document, you have a Word file, okay, and you also created some Excel file. Okay, these are the three things which are parallelly created by you on your system now. So when you start working on these applications, you can't work on all the application at once. So your operating system will create you a time slot. Okay, so when you open this Word file will be in a queue. Okay, and when you are working on Excel, might be image file. Now, for example, understand, you want to print all these applications. You are using a resource called as printer. Now, printer is a resource which is connected to your system now. Now, I want all these three files to be printed, but all these three files will not happen at once. They will be in a queue processing. So the first file which you are going to select, that will be executed first or it will be printed first. So here, according to your time, you are sharing the system resources which are available for different users. Okay. Now I can give one more thing also here. For example, as I told, you have one common printer which have to be shared by four different desktops. Okay, let's take this is D1, D2, D3 and D4 desktop I'm writing here. Now all want to access this printer. So what will I do? I can't give access for all at once. That is impossible thing. So what will I do? First, I will, according to the priority received, like for example, if D1, the desktop one has requested for printer access first, your D1 process will be executed in that time. And later on D2 will execute, then you'll be having D3 and then you'll be having D4. So whenever you have less number of resources in your system, which have to be shared by multiple users, then we choose a computing environment that is nothing but time sharing. What is that is? You are going to have your time slots. According to that time slots, your resources will be shared by your operating system for your individual users. Okay. Now next under this you have client server architecture. What is this client server architecture is? You'll be having only one server machine and you have n clients here. Okay, so let's take C1, C2, C3, C4 and C5. Now, what is this client server architecture? Assume that. Now, let's assume C1 is doing different programs, C2, and let's assume all these five members want to use one common file. Let's take, like, for example, abc.c file. abc.c file have to be shared for all these people, that is C1, C2, C3, C4, C5. So instead of creating or sending individual file for each client, what will I do is I will load this abc.c on my server machine. So what happens now? Everyone will be having the access for that server machine and all these clients can use that. Okay, so whenever you have a single resource, that should be shared for equally for everyone. Okay, then I load that application on my server machine and I start sharing that application to clients. Now what happens is, when I load this abc.c file, I can also set my permissions. Either I can set my permissions like only the person can read or the person can write or the person can do any another actions like execute. That is a user, that is now server side program which is going to run according to the different lines. Suppose for example, C3 and C4 need all the permissions. So what do you do in abc.c on your server side? I will create the permission for C4 and C3 as write, and for the remaining clients, I will only make the permission as read. Okay, like for example, you people have your Google sharing sheets, right? When you're talking about Google share sheets, you'll be having different options: read option, view option, edit option, comment option. You can see all these in your real time applications in your Google Forms, right? So that is nothing but your client server. Server side person is creating one application and he is enabling the permissions which can be accessed by different clients from different sources. Okay, a common application that can be accessed by n number of users at a time. Now on that Google Sheet, multiple users can parallelly work. Understood? Any doubt with client server? dear students? Understood client server? Okay. No, client server is not under time sharing. Time sharing is one resource. It can be shared one by one. In client server, one resource can be shared parallelly by everyone. Like Google Sheet, if you take the best example, multiple users can parallelly work on that sheet, right? There is no rule that only one person can work. Okay, both are different. Okay, your doubt is done. Okay, fine. Now the last one under your computing environments is, okay, someone is having some doubt. Okay, someone want. Okay, just 1 second. Someone is asking for client server. So under client server, understand. I will give you a best example. See, someone is asking this. You can once again explain it, ma'am. Client sharing. Okay. So what is this? Is you understand here? In client server, okay, client server. It is not client sharing. It is client server. Only one server you will be having, or you understand more clearly. You have only one document file. Like for example, I told you have a file called abc.c. Now I want to share this file for all the clients. I want to make all the clients to start using of this file. So what will I do? I will load this abc.c file onto my server so that all the clients at a time can access that. Okay. Now, as I told you, you people are working with your Google Forms or Google Sheets, right? Your class teacher might be sharing a common sheet for you, and she will be giving you the or enabling the permissions, like you have read permission on for that sheet, or you'll be having edit permission. You also have comment permission, and you also have only view permission, right? So now this, let's take your class teacher has created a student Excel, that is Google Sheet, and that sheet is created on my server. That is your server is now who? Server is your class teacher system. Okay, she has created that st.xls on her system. Now she started sharing on different clients for your mail IDs. That is by creating a link, she will share you. So this sharing of st.xls will be commonly shared for all the 60 students of your class, and she can also create permissions. Either she want to create read or edit or comment or view, that is her choice. Now, this file is available for all clients, and all clients at a time can do the modifications, or they can add data or remove the data, or they can view the data, or they can comment the data at once. Clear? Someone asked 33. Done? Roll number 33? Yes? Okay, fine. So the next one, next we have something called as distributed computing environment. So why we need to create a distributing computing environment is the question. Yes, correct. Distributed computing environments. So why generally let you are students. So whenever if you are doing any project, okay, when so understand why these many, depending on your situations, you are designing your computing environments. Suppose if you are only see from the beginning. Suppose if you are working for your own application, then your environment, your type of environment which you are creating is personal computing environment. That is, you only are doing, or your own, only one person is doing his own work, or he is creating his own platform. Then you are calling it as personal. Suppose there you want to create an environment where you want to share the system resources, so that when you are sharing your system resources, it cannot be done all at once. Then you go for time sharing. Depending on time sharing, you will divide your work, and you will ask the different applications to run in different time slots. Now when you are having common applications, everyone at a time have to share, then you made your environment working model as client server architecture or client server environment. Now, similarly, you are going for the next type of environment is distributed computing. So whenever you have a large amount of work, for example, you have a big project, that big project cannot be a personal computing. Okay. And that big project cannot be a client server, because there are some things or some you will be having some abstract things there where only few things have to be shared for everyone. So what will I do is, in my distributing, when I have a big project, I will divide that project into different modules. Okay, like M1, M2, M3, and M4. Okay, so now these modules I will distribute, because if I combine all these modules, my complete project is designed. So whenever you have a large amount of work to be completed on time, then you will make your project to be divided into modules, and each modules will be distributed commonly among the users. So for example, you have 10 members working for this project. So I cannot give a one person for the complete project. So what will I do? First, I will divide this project into modules, and I will choose which person will suit in which module. Like for example, you are organizing an event in a college. One person cannot organize all the events, right? One person will be allocated for registration procedure, one person will be allocated for collection of the amount, one person will be in publication, that is nothing but advertising your event, one person will be taking photographs. Now if you don't have distribution there, if you don't create distributing there, what happens? The burden on one single, if you make it as personal, the burden will be increased more. So whenever you have a large task to be completed in a short span of time, then we choose the environment working model as distributed computing environment. Understood everyone? Understood everyone? Distributed computing environments. Sorry, computing and are you all clear with computer system, computer languages, and computing environments? Yes, you can take any example. Yes, correct. Okay. So someone is asking something. Okay, you are all clear. Good. Fine. So one more thing. We'll talk. Okay. We'll talk about creating and program development structure of C program, all these tomorrow. In short span we can complete SDLC, so I'll complete SDLC. And okay, SDLC you can also call a system development life cycle or software development life cycle. Either it can be called in two ways: system development life cycle or software development life cycle. So understand, this life cycle is when you are given a new task, you do division of steps, that is you apply different types of steps. And how those steps include is this: the first phase of software development life cycle is the first one, we call it as system requirements gathering, system requirements. Then the next phase is analysis, then we go for design phase, then we go for testing phase, and the next one is maintenance. Okay, so this is a common thing, generally we do it in our everyday. Like for example, you take a construction of building as first best example. So whenever you are given, you are as a civil engineer, you don't start constructing your buildings first only without doing any of this. First you will understand what are your requirements, like what is your budget, what is your area, all your requirements, that in order to execute your plan successfully is your system requirements. Okay, that is you will be gathering all your requirements which are needed for developing your project. Then you analyze according to your requirements, you analyze your project, okay, how it is running or how you want to continue with the model. Then after your analysis is done, then you design your analysis in pictorial form. Okay, you are going to design your analysis in pictorial form, which comes under the category of design phase. Then you go for the testing, whether you are working, I mean whatever the design you have implemented, whether it is working properly or not is your testing. And maintenance is always your future use. Now you convert this with an example of you want to create a new software. First you will gather what are your requirements in order to design your software. Okay, so how many tools we need, what are your hardware requirements, what are your software requirements, that is how much amount of memory we need, how much space internally and externally we need. All these becomes your sister requirements or system gathering. Then you analyze what is, how your system, I mean how does your software should work, that is for what purpose, what is your purpose is your analysis phase. After you analyze, you start putting it in a pictorial form is nothing but you're doing it in the form of design phase. Okay, after you design, then you test. Testing is what? Whether your analysis is being created with expected out. Your expected outputs are being done in your testing phase. If not, what you do? Again, you go for modifications and again you test. Now, why for any software we need maintenance is understand. See, you people are working on different operating systems. Okay. After you develop your operating system, so suppose if you want to add any new versions, okay. See, for example, you get your messages in your mobiles. If you observe, update the version of the application, right? So what we do, we generally go for update. We don't again do uninstall and again we don't install such things. We don't do. So maintenance is nothing but for future enhancement. Suppose in future, if your application want more user friendly, for the existing thing we do some modifications. That is nothing but you are calling it as maintenance phase. Okay, everyone understood with all these system requirements, analysis, design, testing and maintenance. So SDLC life cycle is this. Anyone has any doubts in computer systems, computer languages, environments and SDLC? Everyone are clear with these four concepts? Okay. So tomorrow I will explain you about how to create your and run your structure of C program. And so be patient. For first unit you'll be having more theory as I mentioned. So as your request, I'm covering all the theory in detail. You want me to brief SDLC? Sure. Okay, I'll start. I'll just one second. I'll be. So SDLC is simple. You want to develop some software. So in order to develop your software, first foremost thing is we do requirements gathering. Okay, requirements is nothing but, for example, you are developing one software. Okay, okay, let's take a best thing. You want to write some program. Before writing your program, we need what are your requirements. Requirements in your program is nothing but how many number of inputs we need and how many number of outputs we need. Okay, requirements are nothing but how many number of inputs we need and how many number of outputs need. After you gather your requirements, you will analyze. Okay, you will go for the analysis phase. That is nothing but how your program or what is your expected output. That comes under the category of analysis phase. Now after analysis, then you start your analysis in pictorial form. That is nothing but design. Okay, after you design, then we do the testing phase. Okay, so testing is nothing but your analysis should match your testing. That is, you should get your expected output. Then you have the last phase as maintenance. Maintenance is always for your future use. Okay, for example, you have developed some software for today, which helps you to maintenance. Okay, okay, everyone understood this? Someone asked me. 61, are you clear with this? So today I will share the chapter 1 notes. You can go through these four concepts. Okay, fine, thank you. You have the next class, I guess. Okay, thank you all. Have a nice day.
Hello, Kirti ma'am.
Stop.
Ma'am, I
I'm
have to
stopping.
stop.